signals and add the UV quantitation in and keep the mass spec signals. So let's take a look at how to do that. Here we've got the mass spec signals quantitated on this batch, but there's also a UV signal here. So let me go over and show you how you might approach this. Here I've got an MRM method with the transitions. Signals look good. I'm going to go to Advanced Task, Compound 2D Setup, and instead of changing the quantitation, I'm going to add in a new compound and another new compound. And then I'm going to transfer some of this information here using a cut and paste feature. And I'll rename these new compounds. I'll just put dash UV in front of them to distinguish the fact that that I'm going to now create them as UV signals. All right, they're both time segment 1. I'm going to declare the 265 as the target and this as the ISTD. And as we have previously discussed, this is a UV signal type, VWD, and that one's a VWD. I can look at the retention times, and I'm just going to, in this case, copy the retention times from here, 285 to 285, and then 265 to 265, so I've copied the retention times. And moving down the list of things to do, here I've got the ISTD set up. Now notice that 285 here has been declared as the ISTD, and similarly I will declare this as the ISTD and give it a concentration of 400, same concentration as the mass spec signal. And on this end, at the 265, I'm good. Let me assign that ISTD here as UV 285. So I've got the relationship again between the ISTD and the target. Concentration setup. Here I notice that I've got a concentration curve. There's the ISTDs and there's the concentration curve for the mass spec signal. But I do not have one for the UV signal. So what I will do is I will copy that calibration curve that already existed to the UV signal, and I'm done with that. There is no qualifier setup here, and the calibration curve setup. I've got a quadratic for the mass spec and a linear, and it looks like I'm set. Now to save just the tiniest amount of time here, I know that there's an offset to the mass spec signals. So for the UV signals that I've set up here, I'm going to update and shift retention times for the UV signals because they're offset a little bit. And I'll pull them back minus 0.1, absolute shift back. And then now I will go and apply the method and analyze this batch. Here we go, back to batch at a glance. Applying the method to the entire batch. And what we saw before was the mass spec signal and the quantitation involved. Now what I'm going to do is go over to the UV signal, and you'll see that the UV signal here is being quantitated in the same batch. And here's its calibration curve. And this really does show the power of having a method for each compound, because we're able to mix mass spec quantitation here and do a verification with the UV signal. So if I look at the quantitated amounts here in the calibration curves, you can see there's the UV quantitation and there's the mass spec quantitation.